This is Insertion Sort implemented in Python. Create a new file called insertionsort.py. In this file, define a function called Insertion Sort, which takes a list as a parameter. If you don't know how Insertion Sort works, I recommend you to check out my video that explains the algorithm. The link will be in the description. I will also link the full code in the description. Inside the function, create a docstring, then create a for loop to iterate I in the range 1 to the length of the list. Inside the loop, create a variable key and set it to list I. Also create a variable j and set it to I minus 1. Next, create a while loop which will run until j is greater than or equal to 0 and key is less than list j. Inside this loop, set list j plus 1 equal to list j and then decrement j by 1. This loop effectively shifts all the elements forward by one index as long as the conditions are being met. After the loop ends, we set list j plus 1 equal to key. That completes the sorting. Now let's test this function. At the top of the file, import rand_int from random and also import time. These are both built-in modules and we'll use them to make our lives easier, though they are not necessary for the insertion sort algorithm. Create a variable to store the number of elements we want to test with and another variable to specify whether we want to print the lists to the console or not. Next, create a function called generateRandomList, which takes the length of the list to be generated as a parameter. We need this function to test the algorithm with large inputs. There's no way I'm going to sit here and input 100,000 elements into the console. Inside this function, we declare an empty list, then we iterate over the required length, and in each iteration we generate a random integer between 0 and the number of elements and then append it to our list. Finally, we return the list. Now below the insertion sort function, let's write the driver code for it. We first generate a random list and print a message that says the list has been generated. If display lists is true, we print the generated list. Next, we sort the list using the insertion sort function we just created. We also measure the time before and after the sorting. Once again, if display lists is true, we print the sorted list. We then compute the time taken by the function and at the end we print a success message along with the time taken. Now let's test this function. Set the number of elements equal to 10 and display lists equal to true and see what we get. As you can see, the randomly generated list has been sorted. Let's try 100 elements. Once again, the list has been sorted. Let's try 10,000 elements. Don't forget to set display lists to false. The sorting has been completed and it took approximately 3 seconds. And now for the prize, 100,000 elements. This time it took approximately 300 seconds. So with a 10-fold increase in the number of elements, the running time approximately increases by 100-fold. I will hopefully compare the running times of different sorting algorithms in a future video and draw some graphs. Alright guys, I hope this video helped you out and you enjoyed the little experiment of sorting 100,000 numbers. If you did, please comment down below. Please subscribe to this channel. I really need to get to 1,000 subs. Come back for more DSA and more implementations of various sorting algorithms. Thanks for watching.